Hello world, welcome back to another tutorial. Today we're going to be talking about scene graphs and how to render multiple objects on your screen at once and move those around individually. Right now we have this one flashy box, which could be the most exciting game in the whole world, who knows. I'm not a judge of games, really, but what we want is maybe multiple flashing objects or multiple objects moving around at once. Most games have AI built in, so how would we program AI into our scenes, So this episode, we're going to render a bunch of different objects on the scene at once. Like and subscribe, hit me up in my Discord channel. A bunch of us have been talking, it's pretty fun. But other than that, let's go. Okay, so back in our game, we currently have one object rendering on the screen, and that's simply by adding a player object to our renderer class and calling player.render in the draw function every single frame. Cool, we could do that. We could totally build a game engine doing that. Not a good game engine, but we could add a player 1, player 2, player 3, and somehow create an awesome game. If you want to do that, go for it. But in our case, we want to add multiple objects to the screen and make it easy to add these to the screen and make it easy to update their position and their animations and whatnot. A couple of you might be thinking, well, let's create a game object array. Let's just create an array of game objects and populate that, maybe first with our player, then a couple of guys that are surrounding me, and then even more guys that are surrounding me, and then we'll tick over this game object array and render every single one at a time in a linear fashion. This is a good idea. I've actually built game engines doing this exact same thing because technically this render could be a tick, then render, and we can, tick this whole entire thing and update the logic and whatnot, and it's awesome. But we come into some scenarios that it just doesn't make that much sense. So say we were to take this node, which is a terrain node, and we want to render that as well. So the terrain is going to be separate from the leaves. So the leaves are their own node. They're the leaf node. LOL, that's a pun. Hopefully you guys get that. But these are the leaf nodes, and these leaf nodes are attached to the grass. So the render would look something like where we render the first one, render the second one. Now we need to render the terrain. So let's go out to the terrain object, maybe create a function that overrides the render, and render every single leaf, and then go back and render the rest. Well, we could totally do that. Like I said, that's not hard to do. Just override the render function. But what if all of these other objects have maybe particle effects on them that also need to be rendered, or other types of objects surrounding them that we want to render those? So we don't want to have to override the render function every single time. So let's take this scene, for instance. How would I render this beautiful car scene with these straight standing up leaves that are about the size of a car? Because this makes perfect sense. Well, what I would first do is I would create a class and I would call it a scene. So we'd have for every single, scene in our game, we would want to populate it with a bunch of objects. In our case, we want a car with some leaves and some grass. Well, let's go ahead and add to our street scene some terrain. First thing we need is terrain. Now the terrain object will add children under itself, create some leaf nodes here. We would then add to the street scene the street, and then we would add a car. So this doesn't look like an array to me. It's basically the image I showed you before, but it doesn't look like an array. What does it look like? Yes, a tree. It's called a graph scene or scene graph, but it's a tree, right? So this is what it's going to look like. There are graph cases where we could, potentially create more of a graph type data structure, but in our case, this is a scene graph. Let's create this because this sounds a little bit more efficient, where the terrain is going to render itself, the street's going to render itself, and the car is going to render itself, and the scene renders all of it. Hopefully that made sense because we're about to start coding it and you're about to get super excited. Let's go. Oh. So back in our code, you'll notice we have this beautiful flashing, getting smaller and bigger square rectangular thing. Cool. That's awesome. Oh my God, I'm so impressed. But we want to put multiple of these things on the screen. So like I said in the little introduction description, if you didn't skip it, is we need a scene. So let's create some scenes. Inside of the game shiz folder, I am going to create a new group and I'm going to call it scenes. And I'm going to put it under node because that makes the most sense. Yes. Inside of scene, I'm going to create a new file. I'm going to create a Swift file and the file will be called scene. Let's go ahead and delete all that crap and say import metal kit, which we probably don't need, but I'm doing it anyway. Why not? Class scene. That will be a node. Like I said, the scene will be the head node of the tree. And so what we're going to want to do is our node class is going to need an array of children. This will make more sense in just a second when I do it. So let's go into node class and create var children. That will be an array of node. And I will set that equal to an empty array. Now, our scene, we can add objects to the children array and we'll render each one of them. How will we render each one of them? Well, the first thing we're going to need to do is we're going to need to add the children. So I'm going to create a new function and it's going to be called add child. I'm going to take in a child node and then what I'm going to do is I'm going to call children.append child. So from our scene class, like, I don't know, in the initializer, we can call add child because it exists now, right? And we'll have our children all available. Cool. It's awesome. But how do we render all of our scenes children? We need their children to render their children and, you know, so on and so forth. So what we can do, and I'm going to try to describe this as best as possible, the way this is going to work. Say we have scene.render. So the render function of the scene is right here in node. Scene.render. Say we have our terrain class, right? In our terrain class, so scene, we say add child, and that's not what I wanted. Add child, and this is probably being like the initializer, but we want to add our terrain. Now our terrain would call add child into itself because terrain is also a node. So we would call add child terrain, and then the terrain game object would call add child leaf, add child leaf, add child leaf, add child leaf. And so what we'd have is inside of our array for children on node, we'd have 4 leaves. So we'd have a leaf, 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 and leaf. And those would have their own animation or whatever, flow back and forth beautifully, waving in the wind. And so what we need to do is we need to render over every single one of those children. So when we call scene.render, well, scene has a terrain. So let's go like this. I'm just going to add it and I'll show you. So for child in children, we want to go child.render. That's basically what's going to happen. We're going to jump into scene.render. We will iterate over all the children in scene. In our case, it's only a terrain. For child and children, child.render, terrain.render. This function will call up back to this function, except now it's on the terrain's render function. Because we called terrain.render basically right here. Terrain.render will then go through all of its subchildren, all of the leaves. So for child right here, child right here, child right here, child right here, call render. All of these leaves don't have subchildren, so it's going to end right here. It's going to get to the last leaf. It's going to call render, and it's going to get to the end. It'll then go and say, all right, do I have any more children? No. Render yourself. Do I have any more children? No. Render myself. Do I have any more children? No. Render myself. And that's kind of how this is going to work, is we're going to add children to children, and they'll render themselves. Apparently, I don't need that. Beautiful. So when we call render on any node, it will render all of its subchildren automatically. But luckily, since node has render, we don't actually need to apply it yet. So in scene, there's going to be one function we'll need, and that will be, okay. Build scene, no parameters, no return type, and the body will be, well, this is just your base generic scene. Really, we're not going to implement this here because what I will do is I will go override init, because this will override the node's initializer, super.init. This will initialize the node. Then I'm going to call build scene. Now, this is our basic prototype for our scene. It's not really a prototype. It is a class, obviously. But this is our scene, okay? We have class scene right here. Let's go to the scenes group, add a new file, and let's make a different type of scene. Actually, this is going to be a real scene. The scene that you see right here is just kind of the make-believe scene. It's the back. It's the, does all the work for us. This scene, the sandbox scene, will be where we add our objects, the in-build scene. So I'm going to do the whole rigmarole of import metal kit. I will go class sandbox scene, and I will inherit from scene, which then inherits from node, which means I still have add child, add children. Pretty cool stuff, if you ask me. And sandbox scene will call build scene, except it will override it. And since this scene on the initializer calls build scene, and it's overridden right here, it will do this one first. Pretty cool. What can we do with this? This isn't connected anywhere. This is just kind of floating. What we can do now is go to our display, go to renderer, and let's, instead of saying var player right here, let's take this var player, go back to our sandbox scene, add it on the outside of there, and really this could be a let. I don't know why that's a var. Go down to our renderer, player.render, take, well, no, we don't even need them out of there. Let's just instead up at the top say var scene equals sandbox scene. And then right here, we can call scene.update and scene.render. But I think scene needs an update function, and it needs to take in a delta time. So back in node, just like render is right here, and renderer scene.render calls the node's render right now, we can create func update. That will take in a delta time, which will be a float. And I will basically do the exact same thing that I'm doing below, and that's for child and children, child.update with delta time. Pretty slick. And then maybe even right here, you just like how we have if let renderable underneath, we can say like if let collidable, pretty cool stuff up there. But I digress. Scene.update, scene.render, scene's right there. If I press play, beautiful magical things are not going to happen because apparently in my game object, so if you guys just go ahead and go over your game object class real quick, you'll notice that we have this update function, but now since the node class has update, we just need to put override right in front of that since we're going to override the update. Yo, what the hell is going on? All right, so let's debug. We're not adding anything to our scene right now. So our scene needs to have a player. So in our sandbox scene, we have player, but we don't actually add them. So add child player. Add child then adds to the children array in node, and then it will iterate over all of its nodes and render player. So now if I press play, the game object has that flashingness on it, not the player object, but we should see this gorgeous thing again in the exact same fashion, except now we have a scene to wrap it all with. Moving forward, if you look at this, the scene doesn't belong in the renderer. The scene is a state. At any point in time on the game, we will have a state that is a scene. So instead of keeping it here in the renderer, what I'm going to do is I'm going to create a new group on the main game engine folder, and I'm going to call it scene manager. Now the scene manager will go right under the libraries, and I will add a new file right here. And I'm going to say scene manager right there. Actually, this isn't going to be called scene manager. This is going to be called managers. I'm sorry. So just rename this group to managers. And now we'll have a scene manager. I'm going to import metal kit. And then I'm going to say class scene manager. And I'm going to implement this real quick, and then I'll talk about exactly what I did. Okay, so basically this is pretty straightforward. What I've done is I've created a scene types enumeration that contains our one sandbox that we've created over here. See sandbox scene. So these are going to be the different scenes that we create over time. And then what I've done is I've created this private static variable called current scene. Current scene will be the current state that we are in right now. So if we're currently on the sandbox or we're currently on the ocean or whatever, this will hold that current scene's value. From the engine, I will call initialize with a scene type. So let's go to engine. I'm going to call scene manager.initialize. I'm going to pass in the scene type, which right now I'll take in .sandbox. Why not? And really, this should be a preference. So I'm going to go into preference. This shouldn't be a preference. This is where I'm going to put it right now. But we'll move it in the future. This will be nice because when we do debugging, we can set the scene dynamically. But for now, I'm going to just say starting scene type, which will be a scene types will equal scene types.sandbox. And then from our engine, I'll just call preferences.starting scene type. So we're going to initialize our scene manager with the current starting scene type. Then what we'll do is inside of our scene manager, we will set the scene, pass in the scene type, which is sandbox, and then we will iterate over those. So we won't iterate, we'll select them based on whatever was passed in. So we'll use a switch statement for that. So the scene box is a sandbox. We will set the current scene equal to sandbox scene. And we can call this is a public function, so we can call this from anywhere we're at right now to do transitions. We can even like create a transition function in here. But what's really important, so this is how we set and initialize the scene. What's really important is that we're taking the rendering of the scene and replacing it inside of the scene manager, so that the scene manager will then take responsibility of updating and rendering the current scene that it is on. And what we can do is inside of renderer, as opposed to creating a scene right here, well, we've already called initialize the scene manager from our engine. And so right here, all we need to do is simply say scene manager dot tick scene with the render command encoder and our delta time, which is right here, 1/float view right there. And then I can just get rid of these two guys. So tick scene of the scene manager will take care of all of our rendering and updating for us, which is really nice because really this is the renderer class, and the renderer should be in charge of rendering properties, not anything else. So we'll say scene manager every 1/60th of a second. We'll call scene manager dot tick scene. It will then call tick scene. I'm just going to kind of go through it. Call tick scene right here. It will call update, which is on the node update, and then it will call render. The render will then go through each child of each thing. So the scene.children, which in our case was the terrain, it will go through all of those little guys and render them. So if I press play right now, same thing, just a lot better design. This is so much better. Another thing to note is that we can add multiple objects. I know that's what you were getting pumped up about, right? That's why we made this episode, was to make us able to add multiple objects. So first thing I'm going to do is go into the game object and just remove all this crap, because really I don't want to do that right now. I'm just going to remove this update. We'll update the model constants, but that's about it. Inside of our sandbox scene, though, we'll want to add multiple children. So let's get rid of this player. Let's get rid of this child. Let's create something kind of fun. I'm going to code this, and you guys just hold your horses. I'll tell you what. Okay, so basically now we have this sweet little function where we're going to iterate from -5 to 5 and then -5 to 5. So we'll get 10 here and 10 here. What we'll do is we'll set the position based on this Y and this X. So for position Y, we're going to take the Y, just kind of ignore this value for now, but we're going to take that Y and divide it by 5, right? So because that's going to give us 0 to 1 value, and then the same thing goes for this value, and then we're going to scale it down a little bit to 1/10 of the size that it should be. And if I run this sweet little function, we should see all of our objects. Look at that. Oh, gorgeous. So gorgeous. So now you'll see we have all these objects rendered on the screen nicely. And if you want to move them, well, what we could do is we can just override func update for child in child. Actually, you know what? Let's go, for child in children. Since we have our children, we can say, let's say child dot rotation dot, I don't know, let's rotate around the Z axis plus equals 0.02. Okay, and then we'll call super.update so it updates. Hey, would you look at that? Okay, so now we have all of our objects rotating on the screen. Holy mackerel. That's cool, right? But I want to get into a little issue that we were having last week. Or not last week. You wouldn't have known about it. You might have known about it. If you figured it out, you're a gosh darn genius and good for you. However, I forgot to mention that really... Let's stop this. Actually, you know what? Let's press play, and I want to describe to you something that's going on. Okay, so right now, if I click this button right here, you see we're rocking 31.29 frames per second. There's only 100 objects on the screen. Metal's supposed to be awesome. Yeah, that's because I messed something up. While it's running, if you click this little camera, and I don't know what this is going to do for my screen, but like if you look at, so that little camera, by the way, is how you debug on the GPU. If you look, we are creating all of our fragment shaders and our pipeline states on the fly. Every single frame. This is one frame. All of this stuff is happening. These make sense because we're setting the vertex, we're drawing the primitives for each object. That makes perfect sense. But this stuff shouldn't be. It's like, look at this. It's like, you shouldn't be doing this. Why? You created a render pipeline state during your rendering loop. What are you doing? I thought you were caching it. Well, let's stop that and let's fix that issue. So the problem is in each one of these, what I've done is every time we call function, we create the function. We call basic vertex. We go into the dictionary. We say vertex at here dot function. It grabs this dot function and creates it. So what I'm going to do is in our function, let's put a bang right there. And then after this function in basic vertex shader, I am going to put a bang, carriage return, initialize it, and then just set that function up top. So hopefully you saw that. I'm going to do the same thing for this function. Init function. And then we don't need to return a function. So what we'll do is we'll call basic vertex shader dot function, and it's already been initialized and cached away in our dictionary. My bad. We're actually doing that for our vertex descriptor too. So go into vertex descriptor, put a bang right here, and then put a bang right here. Return down init vertex descriptor, and just initialize it. Don't actually create it every single time. And we'll do it for the render pipeline descriptor. I'm doing this everywhere. I'm so sorry. Bad design. So we'll do it here. And inside of our vertex descriptor, we have it. Render pipeline state needs it. So right here, we're going to put a bang. And then we'll create a bang right here. Do initialize. Instead of initializing with this variable, we'll just be updating this guy. And then we don't need to return anything. It'll just set it. I'm going to run the build function right here. It looks like we don't have a... We'll need to put a bang right there. So hopefully you saw that. By the way, since WWDC was this week, they released Swift 4.2. I might do that at the end of this episode. It's a very easy process. You just kind of click a button and it does the work for you. But now I'm going to run. Look at how much faster these are going. Go here. We're back up to 60 frames per second because we're not creating render pipeline states on the fly. That's why it's important to cache these things. That's why the library episode was so important, because now we're caching correctly. Yeah, let's bring that back up because that's pretty awesome. Look at how nice this looks. Super smooth. Bunch of objects rendering on the screen at once. This could be... Oh man, this is going to get really fun now. Now we have the we have the functionality to create multiple objects, doing multiple things. I don't know. We're getting pretty far. We have a long way to go, obviously, but this is getting pretty cool. We now have a bunch of freaking objects rendering on the screen, like I said we would. Pretty exciting. Hope that was informative. So yeah, if you like that, please just go ahead and thumbs up this one, or subscribe, or do whatever you do. Go ahead, hit me up in that Discord channel, like I said at the beginning, and yeah, catch you later.